Okay, good afternoon. I'm going to be explaining my ALU lab assignment. So I continued with the half adder, full adder, ripple carry 4, adder 8, and subtractor 8 modules that we created from the previous lab assignments. I created the AND gate for the module. I created a bus A and B uh, as inputs going from 0 to 7, and a bus for Y output going from 0 to 7. I then mapped into each individual one um, to Y0, Y1, 2, 3, etc. And I did the exact same thing for the OR module, except without doing AND, I did OR. And then uh, for the set less than, I created the bus A and B 0 through 7, and the output reg 7 through 0. I then checked the condition. If A was less than B, we would set Y equal to the 8-bit value of 1, and if A was greater than or equal to B, Y would be set to the 8-bit value of 0. The next module we created was the MUX module, where we created a bus for 7 through 0 for each individual variable. So D0 had 7, D1 had 7, D2 had 7. And we created a bus for 7 for S that went from 0 to 2. And our output was assigned to Y, which was for 7 through 0, which we used from these Y's up here. So in this case, we would set the 3 bits values of Y equal to D1, and we'd increase each bit value by 1 and assign it to the next D variable. And we ended that module. And then for the ALU, we created 3 buses, sorry. The cell, which went from 0 to 2, the A and B, which went from 0 to 7, and our output and result. We then wired these and assigned the AND 8s, OR 8s, adder 8s, subtractor 8s, set less than 8s, and MUX 8s equal to their inputs and outputs. And we had an OR gate heading through for each 0 flag and result, which ended with the end of the result. And that was that. So created the test bench, each output, and when I go to run the schematic, I have this. Let me see if I can't. Okay, so yeah, when I click on each adder, as you can see, try and make it easier to see for you. It's larger. Open up this one as well. Open up this one. So these were our ANDs. These were our ORs. This was the MUX module we created. These were the things we created from the previous labs, the RC40 and RC41, and we put it together for the module 8-bit. This was the schematic I got. Let's see if I can scroll to the left, make it easier for you. And then when I go to run the simulation, see how I can make this simpler. There we go. This is what I got for my timing diagram output, and I will copy and paste the actual outputs that I got into the Word document and link this to YouTube. So